Now we're going to take a look at how to do subtraction. So remember, we're dealing in base 8, and because we're dealing in base 8, that means we are only allowed to have numbers 0 through 7. Now, whenever I have to do any subtraction, I need to remember that if I borrow, I take 1 off of that column, and then I add 8 to the digit on the right. So let's go ahead and get started. So I'm going to have 5, 6, or 8. And I'm going to do my subtraction. So when I go to subtract 8, I don't have enough. So I borrow 1 from here, and I have to add 8 to 3, giving me 11. So 11 minus 3 is going to give me, or 11 minus 8 is going to give me 3. When I come over here, again, I don't have enough. So I have to go all the way over to the 4. I borrow 1, which I add 8 here. I have to borrow from that, so now I have 7, and I add 8 here, which gives me 9. So 9 minus 4 is 5. 7 minus 6 is 1. Here I have to borrow again. I add 8 to the 4, giving me 12. So I have 37153 base 8. All right. Now this next problem is a really common problem. So we have to figure out all of the bases where this statement can be true. And remember on the right that this is in base 10. And because this is in base 10, we want to go ahead and we want to rewrite this in terms of base 10. So remember that every place value that we have here is a power of b. So this is b to the 0 or 1, this is b, and this is b squared. So I can expand this to give me 4b squared plus 2b plus 5, and then minus, and then I'm going to have this over here. So 16 base b is going to give me b plus 6, and then I'm going to have that times 32 will be 3b plus 2. And so now I have to go ahead and I have to multiply this product and then subtract all of it. So that will give me 3b squared plus 20b plus 12, and I have to subtract all of that. So when I go ahead and subtract all of that, that will give me b squared. 2b minus 20b is minus 18b, and then, 5 minus 12 is going to give me 7, and that is all equal to negative 84. All right, so if you're looking at this, you should be thinking, oh, okay, I got a quadratic. I have to make it equal to 0 so I can factor. So b squared minus 18b plus 77, which factors into b minus 7, b minus 11. So that gives us two possible bases, 7 and 11, that can make this problem true. It's really important that you're able to think in terms of how you can expand out all of the place values to essentially give you what looks like a polynomial. All right, in this last problem, this one here is something I never have seen before. Granted, this is my first year doing math team, but I still had never seen anything like this. So the premise of the problem is that we're dealing with these fractions, and when we have fractions in base 10, we can write them as decimals. However, when we have our fractions in other bases, they are called a radix fraction. So we see this example here, and they start out by telling us that if we had 0.35 in base 10, that's like saying that we have the whole number 0 plus 3/10 plus 5/100. You can also think of that as 3 over 10 to the power of 1, 3 over 10 to the power of 2. And the same thing can be said for if we were to have a decimal in base 6, we just divide by 6, divide by 36, and so on. So what we're supposed to do here is we are supposed to convert this fraction, 13/16 in base 10, into a radix fraction in base 6. So first things first, remember when it says a radix fraction, we can see here that that is actually going to be a decimal, okay? And so I am looking for the decimal equivalent of this fraction. So the way that I went through and did this is I used the standard algorithm that we use to take a fraction and turn it into a decimal. So that way I could apply that same algorithm but with a different number base. So let me show you. So if I were to have this fraction 13/16 and I wanted to go from a fraction to a decimal, an algorithm that I can use to do that is I can repeatedly multiply by 10 until I have no more fractional parts left. So this would give me 130/16, and that is going to simplify to 8 1/8. So I'm going to save that whole part for later, and that will be my first value after the decimal point. And then I'm going to repeat this process with the fractional part. So I'll say 1/2 times 10. I'm sorry, this is not 1/2, this is 1/8. Okay, so I'll say 1/8 times 10, which gives me 10/8, which reduces to give me 1 1/4. And again, I'm going to save this whole number part, and that will go right here. And then I'm going to repeat the process with the decimal. And this will give me 10/4, and 10/4 reduces to be 2 1/2. And yep, you guessed it, we're going to save that whole number, put it over here, and repeat the process with the 1/2. And looks like this will do it. We have no more fractional pieces, so we are all done with our expansion, and we now have our 4-digit decimal. Okay, so if we wanted to do that same idea with base 6, all that we're going to do is everywhere that I multiplied by 10, instead of multiplying by 10, you got it, I'm going to multiply by 6. So let's go ahead and let's parallel this process, but for base 6. So I'll start with 13/16. What am I writing? Oh my goodness. And multiply it by 6. And when I multiply that by 6, that is going to give me 4 7/8. So there's the 4. And then I have 7/8 times 6, 5 1/4. 5 goes over there. Then I have the 1/4 times 6, which gives me 1 1/2. 1 goes there, and 1/2 times 6, which gives me 3. And there is my final answer, the radix fraction in base 6 of 13/16.